Today's topic is going to be one of the largest topics you're ever going to learn in calculus. So to explain this topic, let's first start off with a problem. Alright, so we have the integral of 2x to the power of 3 plus 1 to the power of 7 times x squared dx. Now this is a problem we can't solve by our normal means, because we can't, since we can know this from derivatives, we can't treat a group of terms as a single variable. So we can't just say that the derivative of this thing would just be 1 over 7 times 2x cubed plus 1 to the power of 8 actually. We can't just say that this is equivalent to the integral of that, because we know from the chain rule that we can't just do that with groups of terms. Alright, so how do we solve one of these? So remember how we got a u in the chain rule? Integrals, this rule, which is called the change of variable rule, helps you deal with groups of terms under a bracket. So let's relate this back to the chain rule. In the chain rule, we found out stuff using u. So let's just take the same step. Let's call this our u, thing that's inside our brackets. Let's call it u. And then comes the interesting part. Instead of dx, we want it to be du, because in our derivatives we had dy dx. We wanted it to be an expression of du. But now we want this dx to become du, so we can replace the u with that. Okay, so how do we get this into du? So let's put down our u. So u equals 2x to the power of 3 plus 1. And then we would want to find what du is. But what is exactly du? Okay, so let's find that out. Okay, if we have dy over dx, which of course is our integral, we can just say du over dx, which is the derivative of the equation of u. Okay, now we see that we have our desired thing, so du. So this would equal fx primed. Okay, and then how do we get our du? Well, it's the same thing, since I mentioned that dx and du can be used basically just like any other thing in an equation. So multiply both sides by dx and we get du equals f primed x equal dx. So what does this mean? It means that our du is u primed times dx. So du equals 2x to the power of 3 plus 1 primed dx. And prime means taking the derivative. And we know that taking the derivative of that, we get x to the power of 2 times 6 plus, well, there is no plus because that's a constant, times dx. So du equals that. And here comes the part here, because we don't exactly have this. Let's look at this equation. We don't have this to transform it into du. But we do see that we have our x squared. And that's a crucial part. If we don't have this x squared, then we can't use the change of variable theorem. Alright, but where do we get this 6? Well, we can actually just add it on. But wait, for one thing, adding a 6 on here won't make this the same equation. So we have to compensate in a way. So since we added a 6 here, we basically multiplied the entire thing by 6. So to compensate for that, we have to multiply it by 1 over 6. And we can place that on the outside. Great. And now we can see over here that this is equal to this. And if they're equal, it means that they're the same. So this can be traced back into 1 over 6 times this inner thing is u to the power of 7 times du. Alright, so this is u because we defined it as such, and this is du because we solved that for that there. And now that we found that, we can treat this just like any other integral. So just put u, imagine like you're using x, so this would be the same as saying dx with that, except it's just using different variables. Alright? Okay, so what's that? So you can just use the fundamental theorem of calculus. So it's 1 over 6 times u. 7 plus 1 is 8. And then we put 1 over 8 over here. And this is what we're going to get. Well, we should actually plus a plus c because this is an indefinite integral. Okay, 1 over 6 times 1 over 8 is 1 over 48 times u to the power of 8 plus c. And that is our answer. But hold on, we haven't put u as x yet. So let's just substitute it back. U equals that, substitute u with that expression. 1 over 48 times 2x cubed plus 1 to the power of 8 plus c. This is our answer. Well, I just told you here, I'm just going to call the u method. Later in this video, we're going to tell you how to use a quicker method, although it might need a bit more deeper understanding of calculus. Okay, let's move on to another question to reinforce this. Alright, let's use something like this. 2 to the power of x squared minus 3 to the power of 5 times x dx. Alright, let's do this now. Okay, first step, like we said earlier, is to find our u. What's inside the bracket? This is inside our bracket. Let's call this u. So u equals 2x squared minus 3. And what is du? Remember what du is? We proved that du is just equal to this, to the derivative of u times dx, which is equal to 4x dx. Alright, now we have to find a method to turn this x times dx into 4x. And remember that we can just place a 4 here, but we have to compensate over here. Alright, and then turn this into du and turn this into u. And we'll do that right over here. U to the power of 5 times du. And then since this is expressed in u, everything is expressed in u, we can solve it like a normal integral. 1 over 4, 1 over 5, u, well, not actually 1 over 5, it would actually be 1 over 6, u to the power of 6 times, well, actually plus c because we're taking an indefinite integral. Alright, and then we get that, we put the fraction back in, 24, u to the power of 6 plus c, and then we substitute u back for its original equation, which is 2x squared minus 3. 1 over 24, 2x squared minus 3 to the power of 6 plus c. Alright, and that would give us our ultimate answer. Okay, next problem. Let's say it's this. T to the power of 3 minus 1, t squared dt. So, what is our u? Well, what's bracketed in here? Well, it doesn't seem at first that anything is bracketed, until we realize that this is basically equivalent to 1 over to the power of 1 over 3 to the power something like that. And then we can see that our u is this. U. So u equals t to the power of 3 minus 1. Du equals 3t squared times dx. Here we can add our 3, compensate outside. We transform everything into their u counterparts. U to the power of 1 over 3 times du. We take the derivative, integral, sorry. U, what's 1 over 3 plus 1? It's 4 over 3. And divide by 4 over 3, that's 3 over 4. Plus c, and we do the multiplication, 3 over 12, which is equal to 1 over 4, u to the power of 4 over 3, plus c, and replace u with t squared minus 1. And there's our answer. Okay, these formulas, these methods are all what we use but there's always a part where we have to find u, take the du. Well, there's a faster method. I'm going to call this the faster method. Okay, so let's solve this except using another method. Okay, so let's go back to the original question. So what is 2x to the power of 3 plus 1 to the power of 7 x squared dx? What is that? Remember that dx is basically taking the integral with x as its kind of the variable that's that's taking the integral of. But remember how we couldn't put this as a single integral? It's because this kind of restricted us. So if we change this x into this this little part, then we can actually take the normal integral. So first of all, we have to find something like this. So what is d 2x3 plus 1? So what is the d of the bracketed part? Well, that equals d over dx times dx, because this would cancel normally. But let's leave that there. And just like in the previous videos, we know that d over dx times something equals that something of the derivative. So we find that the derivative of that would give us x to the power of 2, 6, and 1 just leaves there, times dx. So we know that this immediately translates into d2x. So if we work backwards, we know that that equals that. And if we just take the 6 out, we can see that this immediately matches our part over here. Now, to help you understand a little bit better, let's see it put to use. Okay, so we kind of take the integral, because working backwards, we see that taking the derivative is taking the integral. So if we work backwards, just like from here we got to here by taking the derivative, we work from here to here by taking the integral. So what's the integral of x squared? Well, that would give us we put it inside. So it's the integral of x squared. It's x to the power of 3 times 1 over 3. But then we have one problem. This doesn't look like that yet. But remember, when we take an integral, remember where we have a plus c? We can use c and set to whatever we want. And over here, we have 1. So we can just set c as our 1. Just like that. Alright, but something's missing. Over here, we have a 1 over 3, but we want a 2. So this times what equals 2? This times 6 equals to 2. So we can just replace this with 6. But then remember, we have to compensate, so we'll put 1 over 6 here. And now since these, well, sorry, this is not 6, this is a 2. So now that these two things are constant, we can solve it like a normal integral. So that equals here times, we're not using that anymore, times 1 over 8, 2x cubed plus 1 to the power of 8, which equals 1 over 48 times 2x cubed plus 1 to the power of 8. And that would give us our answer. Well, at first, it might look like the U method seems a bit more intuitive. The bottom one actually will make a lot more sense when you get to know more calculus. And just by looking over here, the length of this is much longer than this. So this method is actually much faster. Okay, let's review what we just did. We proved that going backwards from here, we have to take the derivative to get to this. But if we work backwards, we know that this to the power of the integral of this will get us over here. So we try to match our thing so this equals that. So, and if we have a constant over here, we can shove it in there, except we take the integral of it. And then we compensate, and then we get our final result. And just one more practice over here. Here, the problem we are faced with is 1 over 4, whoops, it would actually be 2 x squared minus 3 to the power of 5 times x dx. Alright, so we know that we can put here over here, except we just take the integral of it. So we get 2x squared minus 3 to the power of 5. What's the integral of x? Well, it's 1 over 2 times x to the power of 2. Okay, we see that we have a something over here though. It's a 2. We have to multiply this by 4 to get to 2. So we put it 2 here, but we have to compensate over here by 1 over 4. And now we have a constant, but since we're taking the integral, we have a plus c. So that c can be negative 3, and we just place it there. And then we can solve it just like another integral if this entire thing was x. So we can say 1 over 4 times 1 over 6 times 2x squared minus 3 to the power of 6, bracketed. And we can say that that would equal to 1 over 24 times 2x squared minus 3 to the power of 6.